let's say we have this, this is original image, and then we have two methods. Let's say one, what we improve this image, and then second one, this one. Now the question is that how computer can understand what the best among this. Let's say I have another examples, but in this case, there are two questions here. You have these two images. We have to make decision, they're similar images, or what the best image. There are two different problems. And then the computer has to understand what the best, and are they similar, these images, or the same person, or some others. This is what two questions which you will investigate. But this is another problem which we have images which depend, image enhancement algorithms, which depends on parameters. Let's say A. And then this is parameters for A is equal 0, that's mean original image, and difference parameters. And now, again, the question is, how computer can choose the best parameters? Now I will give you another examples here, simple algorithms, which will show this thing. Let's say you have this image, and then you are doing so-called Fourier transform. What is Fourier transform? That representation in image by combination of sine and cosine transform function, and then this is what you are doing Fourier transform, and then this is coefficient, and then image enhancement is very simple. You are taking this coefficient, taking absolute value, modulus, and taking power alpha minus 1. And then changing alpha, you will get different kind of quality images. Now the question is, again, what the best image, what the parameters? What people are doing, they are testing. All students, many people are doing this way. They are trying to, by hand, to choose. Check one parameter, second one, third one, eventually make decision, what the best one. That's what when I started working on this problem, we had hundreds of methods, and then maybe, I don't know, videos and so many, and then we have to detect small object, tank moving, and then you have to detect. But you have to enhance because it's war, the quality is so bad. And then we had hundreds of methods, and the first day we had 10,000, and then reduced them 100. And then among 100, we had to choose the best one and real time. That's what I started to work on this problem. Now, and this here, we are showing that now we have two parameters. One, this what image enhancement is power, alpha, how to choose the best alpha. But the second, there are different kind of methods. Now we have two different problems. How to choose parameters and simultaneously how to choose the method. This is what I said, that we use 100 wavelets to do this kind of thing. Okay, now this is what examples. Practically, it's recently we developed this in Armenia, Raj. And then here what we have, this is images, a different kind of image enhancement. It's totally different thing. And then we wanted to see how we can choose the best one. It's understandable, yes, there's several problems, but all the same thing. And this is what here. Now, we are doing a little bit more harder problem. We are using different combination of image enhancement. And then also we are using different kind of combination of image enhancement. Now you have the difference method with combination. We have 3 parameters or more parameters on how to choose the best one. Now applications is so many. Image transmission, testing, and so on and so on. A lot of application. Now, the problem we can formulate this way. We have input only one image. You don't have anything. And then computer has to make decision, is the best or not? Is good image or not? Okay, this is what the problem. Practically, there are two approaches, using neural network and then using simple way. This simple, I will explain simple algorithms because when I developed this, it was the government job. They needed to have this output. It's very fast and real time, seconds. This is what we will do it. Now, this is what problem formulation. This is you have one image, and then you don't have any reference, any information about this image, and then you wanted to make decision of this quality. And I will say this is what I developed this 1996, and then published 1999. And now I have approximately 50 publications in this subject and became new area of research, non-reference quality image. Okay, and now what this is the problem which it can solve. This method, you can choose monitor image quality, and then you have compare, make benchmark to choose the best algorithm. You can optimize parameters, and then also benchmark image system if you are doing several steps. And also you can use to fuse images. Let's say you have two images, how combine this image, get the third one. And then also use only about this idea to create image similarity measures. Okay, now, what people doing, how they solve this problem in the beginning? They solve using so-called entropy. We develop Shannon, in US Shannon, and here in Russia, another. Now, but entropy is not good method. Why? Because look, these images visually are different, but entropy, which people are using in neural network everywhere, it shows the same result. This is all this equal because it's based on histograms and this beta image, which is developed here. Look, this image, we shuffle rows and then shuffle pixels, and then you can see entropy, and then another entropy is another modification of Shannon entropy, standard deviation. You can see the images are totally different, but but numbers are the same. How computer can understand this? Okay, and then this is what the measure, which is very simple, developed. This is the first measure which we developed. This is 1996, and then this is recent for thermal images. Now, idea how we can create this image, this measure is very simple. Let's say you are having image, you are taking block by block, three by three blocks, and then this is what taking this 3 by block, and then taking maximum values, and then taking minimum values, and divided this, and then taking a log, and then creating image, and then summing. It's very simple algorithm. And I will say this is very simple, but US government gave me $500,000 to continue this because it's so powerful. It's surprising. And now we have several, I will say color cases, 2,000 citations or 1,000 citations. That's so popular. Okay, now this is what I did, the same idea how we're creating. Now a little bit history. This is what I developed and publication. And now I said that it's new direction on image process. Second question which we will investigate here is this. Linear algebra, that's what classical algebra is not good for image processing application. Let's say neural network, you are doing addition, subtraction, yes, and the first. And then what you will see that, what happened? Let's say visually see what can happen here. Let's say you have these two images. If you add this together, what will be this image? If you add this image with this image, you will get this image. Yes? And then it's not good because this image is good, this image visually good, this image visually good. You are adding together, getting something which visually is not realistic. And then now, when you are using in neural network or other places, you have to do additional tricks, which is computer doing, or sometimes you have this problem. And this is what linear algebra, and then this is what new addition. Now what we did, we introduced, I will formulate later, the algebra which we will use here, which based in human visual system. How human visual system adding two images or subtracting two images. But that's what we will do it. Now I will show that why it's not working. Then you will understand the problems. Let's say you have these two images, you are adding this, you are getting this. If you take small block, let's say this part, one block, and then some part of this block, and then adding together your image, it takes from 0 to 155 or 56 numbers, yes? When you are adding together these two blocks, look this, it became 400 something. What computer is doing, it's only looking 8 bits, yes? And then it's removing. That's a whole problem. That's what is coming problem from there. Now, when we do this, and then we put additional requirement. Let's say this image is good. I'm coming here, new person, and then now image you have this, and you are adding my image. The quality is not changing. Yes, it's quality the same. You didn't make bright or dark this part, and that's what we wanted to have, that requirement that will help us to add two images or subtract two images, that we will not lose so much information. If two images are good, then if we add together, it will be also good. That's what we use that for image enhancement and restoration and others. This is new algebra. It's parametric, and this is what algebra. Let's say one image, this is original image. You are taking maximum 255 minus original image. And then addition is this too. You are taking two images minus multiplication of these two images, divided some parameters. It's similarly this. We publish IEEE transaction, you can read it. Now, what we have done to see that this method is working, we took existing method and replace directly simple this addition subtraction with this parametric operation. Look this, how quality is this. And this is images, and then quality, I will show better case. And then here, look this is what original image, and then different kind of image enhancement, and this is our image enhancement. Look this, is bring up. Very simple, only changing operation. But you have to fill these operations, yes? This is what, another, this is what breast images, and then this is existing method. This is guy from Harvard University, and then this is what ours, unfortunately, if you see that white spots, this is cancer. You don't have practically here, but you can see cancer there. Okay, that's what, only changing operation, you're already getting some good result. This is another cases for medical images. Now, a little bit more, this is what one image, but this is hotel. It's very hard because in image processing, when you have white, dark place, and then also white section, it's always hard to enhance, but it's working so well. And this is another enhancement. You can see practically we are making so good enhancement, it's become 3D images. Okay, now, based on this operation, we decided to introduce new quality measure. Idea is this, This is human visual system based Weber law. This is entropy, classical entropy. We want it, and then also this is logarithmical new operation. We wanted to combine all these three and create it new so-called entropy, and then will help us to do this measurement. And this is what, this is entropy, this is one model, entropy, this is Michelson, this is another model. Okay, this is another human visual model, and then we are trying to use this to create images. A simple idea is just that this is what image, and then we are doing this. This is max, min. This is what I said, that small blocks, image in small blocks, taking maximum divided minimum. But here we are adding something additional things. What is additional things? If you, let's say, I will say it's called GND, but I will explain this way. Let's say you are having coffee and you want it to make sweet, and then you are putting sugar. If you put a little, you will not see anything. But if you add slowly sugar, and then you will feel that it's sweet. The same image, visual system. Human visual system is not seeing everything. It has some kind of threshold. Under that threshold, we don't see it. Okay? Well, that's what this threshold we are plugging here. That's what, because we don't see it, we decided not to include this information there. That's why we are having this image, and then taking only this part. Each block, let's say 5 by 5 blocks, center we are replacing with this value, and then creating this image, and then having this image, and then we are adding together. This is what adding together, that's what we will call image quality. It's very simple definition, but it's so practical information. Now, let's look at what we have here. Now, I'm coming back to this problem, the choosing problem. Let's say image we have, and then we are taking Fourier transform. This is Fourier transform. And then we are taking a coefficient, alpha, and then doing inverse Fourier transform. This is what this part is here. This is coefficient, Fourier coefficient multiplying to this and taking alpha. And then this is what alpha. And then this is what one parameters. A second parameters, let's say you are choosing different kind of method. Second parameters, this is, that means we are putting these methods here, and then parameters value is here, and creating this 3D, the image book. And then taking maximum value, that means we are getting maximum value, that is the best method, and then this is the best parameters, and then you are having this, and then you will get this output. And then now you can see the measure only using what this simple measure, and this is what choose the best parameters is 93, and then this is AME measure original image, and this is what parameters, how it changing. That means you have one image, then a very simple algorithm helping us to make better images. And this is another Michelson with this new algebra. Here, if you look this, the minus, I'm using new algebra, addition new algebra, this is the same concept. This is entropy concepts, and this is, we are giving some kind of weight, and then we are creating this image based on this image, and then combining this all information, and then we are getting the score, the best. Yes, okay. Okay, now I'm coming back to this problem. Problem how to, these images are similar or not. Now, okay, there are different kinds of similarity measure, and today they talk. This is mean square error. This is mean square error. This is oh my God, I forgot. I will tell you. This is Chebyshev. This is Manhattan. Manhattan distance. And distance, let's say this is block, the street, and then distance between here to here. This is mean square, this is Manhattan distance, and this is Chebyshev, and this is what Minkowski measure. Now, why we are bringing this? If you look at these images are totally different. Mean square are the same. Differences between this. But you're all using mean square and neural network, yes? That to handle that, what you are doing, you are adding more information, database and layer that you will be able to fill this. Okay, this is measure. Now you can see that my measure is distinguish all this. That's mean we will very simply distinguish, not only distinguish these differences, but also we can pick the best one. This is what one, and you said that, thank you. And I didn't specially put conclusion because I'm thinking, I will say my conclusion is this, that you have two, let's say, rabbit. Yes, you have two rabbits. You learn how to handle these two rabbits, and then months later, it became 4. And then you started to work with these 4, learn how to handle this. It became 16, and so on. The research also this way, different kind of applications. Okay, thank you.